Hello and welcome to our talk on what it takes to train the next generation of cybersecurity professionals. My name is Dr. Mark Shaneck and I'm the lead cyber solution engineer at CYBRScore. How do you design, build, and deploy scalable assessment and training solutions that can be useful for individual and group knowledge, skill, and ability development needs? In other words, in order to address the gap between the needs of the cyber workforce and the available training talent pool, we need to train people. And not just people, we need to train individuals as part of a group. It's impossible for any organization of any substantial size to have only one cyber employee, and it's completely ineffective to have many individual cyber defenders attempting to protect the organization's resources. So the question is, how can we effectively and economically train teams of people to take on the challenges that we face in protecting our data and our systems? Now, most current training offerings are a one-size-fits-all solution. There is a course, a curriculum, maybe that leads to a certification that all trainees complete. Or maybe it's self-directed, with the trainees selecting which courses they want to take. These courses are often expensive and do not reflect the complex nature of learning in the modern day. People come into this field from a wide variety of experiences, with a range of backgrounds, and pick up a lot of information, techniques, and skills on their own through their current work or potentially in their spare time. So when an organization decides to put together a team of professionals, there will be a unique set of knowledge gaps. If you put everyone through the same training program, you will undoubtedly be faced with wasted time and money training people on things they already know. Or you may be left with gaps in the team's skills and abilities that were not met by the chosen training program. What's needed is capability-based training, where you can assess what skills people already have, what capabilities they bring, and compare that with a set of capabilities required for a particular job role, all designed within an individualized training plan that can get you to that point without wasting time and money retraining people on topics that they have already mastered. This is what CYBRScore brings to the table, a system to provide you with a snapshot of your team's skills and abilities, as well as identify knowledge gaps and a customized set of training materials to efficiently and economically bridge those knowledge and skill gaps and provide you with a mission-ready cyber team. And by mapping this to the NICE cybersecurity framework, or any other relevant framework, such as the Saudi Cybersecurity Workforce Framework, we can match the training to defined job roles to outline what skills and abilities are needed for your team. Before we get into the details of how our solution works, I'd like to provide some background on the CYBRScore business. CYBRScore is a brand name within the greater Comtech Telecommunications Corporation, specifically the Mission Critical Technologies Division. Comtech provides information security around the world, from location-based services for telecom carriers to satellite communications and mission-critical technologies on the ground. CYBRScore draws capability and experience from the Comtech family of companies to deliver best-in-class solutions to meet customer requirements. Comtech MCT is a trusted provider of command control, computers, communications, cyber intelligence, surveillance, and reconnaissance solutions that military, government, and commercial organizations need to enable seamless, highly secure communications between fixed, remote, and mobile operations under conditions that demand the highest level of reliability, availability, and security. The Comtech Cyber Division is composed of two groups. The Cyber Services team is focused on large customer schoolhouse training. This group provides high-capacity training at scale. The Cyber Solutions group, which markets under the CYBRScore brand, provides training tools such as courseware, labs, and assessments. We package these components into solutions based on customer needs. The CYBRScore group began as a small training program providing hands-on penetration testing training to niche customers. Those programs grew primarily due to their highly hands-on nature, and Solver Innovations was acquired by Telecommunications Systems as a means to bridge into the developing cyber IT market. Two large schoolhouse wins propelled the build-out and development of the team, as well as development of additional products and tools. In 2016, to align with our performance-based assessment tools, we rebranded the solutions team to CYBRScore. Here's a quick view into some of our current customers. Our focus areas include government, corporate B2B, and higher education. CYBRScore provides tool sets that complement each of these customers' overall pathways to success. If you visit our cyberscore.io website, you can get a deeper dive into our customers and solutions. So back to our original question. How should organizations provide efficient and economical training solutions to maximize the impact of training and remain within budget. It's with targeted training based on skills assessments. We accomplish this with the cycle of assess, plan, and learn. The idea is that we conduct a baseline assessment that evaluates the skills and abilities of students, mapping this to the relevant framework, which results in a personalized learning plan. We then execute an individualized learning plan, and finally complete a baseline assessment. From that reassessment, we measure the amount of improvement as well as determine what further training might be required to close any still existing skill and ability gaps. Our focus in this talk is on workforce development, but you can also make use of the assessments by themselves for job placement and hiring by using them to pre-screen applicants to verify they possess the requisite skills and knowledge needed for the role. We achieve workforce development success with our complete training solutions. First, we have our skills assessments, which are hands-on, task-based evaluations. The students are scored on their hands-on skills, not by answering multiple choice questions. Since the cybersecurity field is a hands-on field, it's important that what gets measured is their ability to accomplish tasks and achieve goals in a real hands-on environment in ways that are aligned to an applicable framework job role, as mentioned before. The assessment phase generates the recommendations for training. This training can be a more traditional form of courses, either in person or virtual, and covers a wide variety of topics, some of which are listed here. We also have a team of content developers ready to build new courses and coursework as needed. The courses that we have rely heavily on our hands-on labs. The labs encompass the bulk of the training experience and can also stand alone without a traditional lecture-based course. This is what allows us to achieve a personalized learning experience. Each lab is self-contained, including the instructional material and the virtual environments required for the training, all in one package. The labs are targeted to specific skills and capabilities, and are also mapped to the related framework objectives. We currently have over 400 labs covering a large number of in-demand cybersecurity topics. These labs are generally geared at about an hour in length, with some longer and some shorter, but all generally bite-sized sessions that can be fit into a currently employed student's schedule. They make use of our online virtual environment, accessible with just an internet browser, and can be accessed anytime, anywhere, on demand. These components enable the cycle of assess, plan, train, and reassess. So the first step is assessments. Each main assessment, like Cyber Defense Analyst PR100 shown at the top, is really a suite of sub-assessments or micro-assessments, and each one is approximately 1 hour in length and tests for associated skills and abilities. Each micro-assessment has a subset of overall work role specific skills that it's testing for. These assessments have specific scenarios that the students must complete. They are given a set of tasks in a realistic environment or a set of goals that they must achieve. For example, they may be given a document describing a security policy, and then they have to go through the machines in the environment and ensure that the machines are in compliance, making adjustments as needed. Or they may be told to configure a secondary backup DNS server that mirrors the primary, and the student will have to know how to accomplish that. Or in the case of vulnerability assessment analyst, they may be given a machine that's vulnerable to some exploit, and they are told to exploit it. In any case, they're required to perform certain high-level tasks, with our system monitoring what they do in the environment and scoring them as appropriate. At the end of the assessment, they're given a detailed report that includes their results, which can be viewed over time to see improvement trends. It also includes the list of personalized training, as we will see in greater detail later. The scores are broken down into the individual sub-assessments, which shows you in detail areas of strengths and weaknesses. The student is also rated according to the individual KSAs, so you can see at a glance which areas the student knows well and which areas show need for improvement. This list is our existing assessments, and this is our assessment roadmap for the remainder of this year and next. We're planning to bring Cyber Defense Infrastructure Support Specialist and Threat Warning Analyst online later this year, and next year we look forward to adding Security Control Assessor, Secure Software Assessor, Systems Developer, and System Security Analyst. So the assessment product is the combination of the job role assessment lab environments and the reporting, which provides the measurable results, trends, and personalized learning plan. To recap, the assessments give the students real environments in which they can prove their skills, and our system automatically scores them. Not only that, but as you will see in the demo, Our solution captures thousands of metadata artifacts from the environment, which can enable deeper insights into the student's performance. The end result of this process is the report. This is all a cloud-based system, so no need to install anything in your environment, and it's fully automated. The student takes the assessment on their schedule, and the report is automatically generated and sent out. Now, the core of this assessment program is our performance score engine. Our scoring engine monitors the systems in real time to determine if the student has performed the appropriate actions. Our assessments are fully hands-on inside the virtual environment. While we do support regular questions and answers, and can include those if relevant, we typically rely on hands-on behavior, which scores the actual abilities of the student. Performance Score makes use of plugins to perform the scoring. These plugins can monitor files, commands run along with their responses, registry entries, and changes to them. WMI, which can give us deeper insight into the current state of a Windows environment and how it's changed by the student, or custom-built plugins to determine if the student has made the appropriate state changes on the system. And that's key, as it's not sufficient to simply look for specific actions done, since there may be many ways to accomplish a specific goal. And so whenever possible, we focus scoring on changing the underlying state of the system, monitoring for the desired behavior of the system instead of looking for specific actions. For example, if you're supposed to add a firewall rule, what we want to look for is the ability for traffic to get into the box on that port, not whether or not they ran a specific command. In a Linux environment, there may be several commands that can achieve the same purpose. And in Windows, you can do things from the command line or through the GUI. For the same reason that it's more secure to deny by default instead of listing out the specific bad behaviors, say in a firewall, it's better to score by looking for state changes instead of attempting to list out the specific set of commands or actions a student is supposed to perform in order to achieve a goal. This allows for more robust scoring that can capture the intended state changes. But at the same time, we capture all the data so that we can tell just how they went about blocking that port, and we can review their approach. This gives us unique insights into the actual performance of the student. Each assessment is broken into specific tasks. Each task is given a specific point value, which can allow you to weight the tasks appropriately and is scored by a rule or set of rules. These are the plugins that we mentioned earlier. We also support task triggers, which can allow certain events to happen after the student hits a certain checkpoint, allowing you to chain events and outcomes, or cause follow-on events to occur. Now all these scores are calculated inside the virtual environment itself, making it quick and responsive to the student. At the same time, however, data is sent to our master scoring server that we call Nimbus, which is running in Amazon Web Services. This allows us to collect the results, organize them by team, and prepare reports that can be sent to the student or the training coordinator. Some of the other features that we support include dynamic test variation, meaning that details in the environment can be randomized so that no two assessments are the same. For example, the IP addresses in subnets where the machines are located can be randomized. This way, exact answers cannot be shared across instances. In this and the next two slides, we have a glimpse of what the report looks like. In the demo, we are going to look at an interactive report in detail, but for now, we can see that the report has information related to the various assessment pieces. First, it gives you your overall scores on each of the micro-assessments. It identifies which areas you're strong in and which areas you're weak in. In each of those, it identifies what KSAs from the NICE framework, or whatever framework is mapped, each area is addressing. It moves on to identify an individualized training plan by selecting which labs from our catalog map to those KSAs, or it could be training outside of our system as well. It just needs to be mapped to the KSAs. It then breaks it down to all the individual KSAs covered by the assessment, indicates your score on the material related to that KSA, and provides the suggested training plan for that specific KSA. The report breaks down the results for each work role by micro-assessments. It gives you an overall score, but also shows you your results for each competency, which is defined by the job role framework. The most important piece of the report is the individualized learning plan. This gives you a list of learning materials that the student can take to improve on the skills that were weak without needing to spend time learning things that the assessment showed mastery of. These can be our labs or other learning materials that have been mapped into our system. The report is updated as you take training, indicating that you have completed the various recommendations. The dot next to the topic header, firewalls in this case, indicates how much it can help you. That is, the training plan is prioritized, showing the areas in which you're the weakest first. The labs themselves are shown in order as well, with the most important labs to be shown first. This can help you maximize the impact of the training. Once the student has taken the relevant assessments and discovered the areas of weakness, they can take labs to improve their performance. This is essentially the heart of our training plan. As we said, you could take some courses from our academy, but the ability to take these individual self-contained labs is what allows us to provide the highly customized learning plans. These labs are designed by our lab developers who have educational experience and bring a sound pedagogical approach. We strive to make the instructions as complete and pedagogically sound as possible, including not only the what and how, but the why behind all the steps in the lab. We attempt to use relevant tools and software in the lab so that students are using the tools that they are likely to encounter in their work role. These labs are also focused on action. They walk the student through specific scenarios, instructing them on what to do along with why it is done that way and what alternatives there might be. Whenever possible, we include information about what is going on behind the scenes. We will show an example of this in the demo with a lab on network scanning. We have two main types of labs, instructional and capstone labs. The instructional labs contain detailed step-by-step instructions, along with detailed insights into why things work the way that they do. The other type of lab that we have are the capstone labs, which offer the student a challenge based on the previous learning that they have done in the instructional labs. Capstone labs don't have the step-by-step instructions, but rather the students are given a task, and they have to use what they have learned in the other labs to accomplish the task. These labs can be used as a checkpoint on the student's progress to see if they have really achieved the learning. The instructional labs can be automatically scored and graded using our performance score engine, and often are, which provides the ability to determine if the student actually went through the steps in the lab or merely opened the lab and read through it. The capstone labs are scored as well, which can provide the score back to the training coordinators to see how the students are progressing through the material. These scores can also be passed back to a learning management system, allowing seamless integration into a pre-existing training infrastructure. It can use LTI or the API to achieve single sign-on and sends the scores back automatically. Note that these labs are using virtual machines and networking, meaning that these systems are indistinguishable from physical systems and provide the students with the most realistic environment possible. We currently have over 400 labs in our catalog, with more being added regularly. As I mentioned earlier, these labs are accessible through a web browser at the student's convenience 24/7. Our labs are available individually, but can also be obtained through bundles. This list is a few of the bundles that we have, and they range from basic security essentials topics to incident handling and cyber defense to malware analysis, digital forensics, and penetration testing. We also have labs that cover advanced web exploitation and binary exploitation. As I mentioned earlier, you can also take labs within the context of courses. We have a number of existing courses. The ones shown here match up with the lab bundles on the previous slide, but we can also create custom courseware as needed. We have delivered these courses in a variety of formats, including live in person in a classroom setting, live online with Zoom or some other conferencing solution, or as asynchronous computer-based training. Our courses are lab heavy, but also include an instructor that provides supplemental lectures to help give the labs extra context and is available to answer any questions the students may have. Now, before we get into the demo, I wanted to highlight a few case studies. The first case study that I wanted to highlight is the Federal Cyber Reskilling Academy, otherwise known as FCRA, that we did in the summer of 2019. We led Cohort 2 of FCRA, which was a U.S. government program to aid in the reskilling and upskilling of government employees who wanted to transition to a cyber job role. Over 1,000 people applied to be in Cohort 2, and we selected 20 out of those 1,000 applicants to participate in the training to transition to roles as cyber defense analysts. The first step in this process was to filter based on aptitude and attitude. To select for aptitude, we are looking for their potential to perform the required tasks given the maximum training and opportunity. Are they good at critical thinking? Do they have some level of STEM background? And so on. For attitude, we are referring to a way of thinking or feeling about someone or something which is typically reflected in a person's behavior. Does their personality align with the traits typically required for a cyber job role? Do they have the passion but also the tenacity required to see difficult problems through to conclusion? We measured each applicant with several tests looking for these unique factors. For instance, would they be satisfied with the job once they transitioned? Do they have the fundamental skills required to maximize their potential for training in this career? And are they substantially interested in this area as a career? The World of Work Inventory, or WOWI, fit the bill most closely, as it was already built, has a long track record of being used to study cyber interests, and has a mixture of all the factors that we wanted to take into account. It measures 6 different career training potentials, 12 job satisfaction indicators, and 12 career interests. This is a sample report of someone who would probably fit very well into the cyber field. Interested in engineering and office work, strong in abstractions, numerical and verbal, and able to do repetitive work, but also very versatile and rigorous. Based on these measures, we were able to organize them along attitude and aptitude. And when you combine these two scores together and sort them in decreasing order, you can get an indication of who would be well suited to retraining. Since we had so many applicants, we were able to select the 20 people most suited to the job role. However, it's also interesting to note not everyone that was selected had a technical background, and they came from 10 different US government agencies, creating a diverse and unique group of participants. In this graph, the x-axis is the candidate and the y-axis is the individual scores, with the gray points being the combination. The graph is sorted in decreasing order according to the gray dots, so we were able to select the candidates from the left-hand side of the graph. We wanted people that had both high aptitude and good attitude, as we believe it is important for both to be present in a candidate for a cyber job role. The selected students took assessments at the beginning of the program, and then were provided a 12-week training program in person at our facility in Germantown, Maryland. The training program covered all the necessary job skills for the cyber defense analyst work role. It included Linux and Windows familiarization, basic security fundamentals, protocol analysis, intrusion detection, incident handling, network defense, and network attack analysis. At the end of the 12-week program, they retook the assessments. This graphic shows the improvements to the scores, with the blue dots being the initial scores and the orange dots being the scores at the end of the program. On average, the students improved their cumulative assessment scores by 73%. Only 3 did not improve a level of mastery. One student was unable to complete the program due to a life-changing personal event. 4 students were already in cyber-related roles and were able to return to their jobs with improved technical abilities. Most importantly, 4 students were able to successfully transition from non-cyber job roles to roles as cyber defense analysts. The second case study I want to mention before getting into the demo is a program that we did for a Fortune 500 company in their workforce development program. This program was organized along 3 different tracks: secure software development, system administration and network operations, and technical support. In the secure software development track, we supported 4 different languages, including C#, C++, Java, and Python. 473 employees participated in the program and followed the cycle of assessment, personalized training program, and then reassessment. So phase 1 was the initial baseline assessment, where the employees took the respective assessments for their tracks. Then in phase 2, they engaged in their individualized learning plans. These students took a combined 5,000 labs, spending over 6,100 hours in hands-on lab time. After they completed all their lab time, they retook the assessments in phase 3 of the program. This graph shows the improvement of the scores overall. The average moved from 27.5% to around 41%, which is an average improvement of 49%. Each employee took an average of 39 labs and spent over 13 hours in training. Not surprisingly, there was a direct correlation between the amount of time spent in the labs and the percentage of improvement seen by the employees. Now we're going to switch over to the demo and see how our system operates. So I have pulled up an assessment here. It's the Field Technologist Assessment and the technical support specialist sub-assessment. So before we kind of show off what's going on here, let me just kind of give you a tour of the interface here. So here in the main part of the screen on the left, we have the virtual machine interface. So this would be where we attach to all the consoles of the machine in the environment. Over on the right, we have the instructions pane. So this includes all the instructions. You can see some extra information here. We have the steps, and each step has a little checkbox next to it so you can keep track of where you are. Now these steps can include things like screenshots and videos as well. There's less in here because it's an assessment, but when we show you the lab later on, you'll see a little more of that. You can also include links to documents. So for example, here we have the task is to enforce standard operating procedures. So we give the document to the students, then they have to look at the machines in this case that are in the environment and make the changes to make sure that it matches the standard operating procedures. So you can look through and you can page through all the different the pages for the assessment instructions. If we click on the resources tab, we see the different resources available, the different machines in the environment. You can select the machine and it'll switch the console over to it. Included in this information here is the username and password. And if you click on the little green text with the T next to it, it'll actually type that in to the machine. You can send Control-Alt-Delete. You can open it in a new window, so you can have multiple virtual machine windows open at the same time. If you scroll down here, first of all, you'll see the list of documents that are available. So you can see the standard operating procedure document here. There's also a list of machines that say hidden. Now those are shown to me because I have a developer account. The student wouldn't be able to see these in their list of machines here. So they wouldn't be able to connect to the console of that machine. However, they are still in the environment. They're still connected with all the virtual networking that's in place. So they're still accessible inside the environment from the machines that they can access. And we're going to show an example of this in a little bit when we change the password of the pfSense machine. There's a help section. Most importantly, there's a link to support trouble tickets if something happens. And you can see here that the default way of interacting with all this stuff is HTML5. So all of this is available and can be viewed with any major browser, any modern browser. You can access this information from anywhere in the world. There's data centers that are located throughout the world, so it would pick one hopefully closest to you, but this would tell you where the data center is, and that might indicate if there's some latency problems, maybe it's in a data center that's not close. If you need to, you can change the font size so you can adjust the interface to be most useful. Up here in the top right, you can end the lab. Students would not be able to edit the instructions, of course, but they could also split the windows if you wanted to split the windows apart to have a separate instruction pane. Also in a lab situation, this would also have the ability to save the lab so that you could save your progress and then pick it back up later if you want. There's a connection strength indicator that can help you diagnose problems of latency. In the middle here, we have a drop-down list of all the machines, so you can select different machines from this. It's a little bit faster that way, but you can't access the username and password like you can on the Resources tab. This gear is only available for developers, so I'll pass on that, but we have a display, so you can interact with the display, change the size, and even reconnect if there's some connection problems. And then here we can interact with the machine in question, sending Control-Alt-Delete, interacting with the Windows key, or even interacting with the clipboard, resetting the machine, and so on. So a little bit about that. So now let's go in here and access the machine. So we'll type in the password. Now the first thing we're going to do here is bring up this score window. Now the score window wouldn't normally be accessible inside a lab environment, or rather an assessment environment. You don't want the students to be able to game the system watching their scores. However, in a scored lab environment, it would be accessible. Now you can see here there's a total of 97 points possible. We currently have a score of 0. And you're going to get to see how this gets updated in real time. Now the first task we're going to do is reset the password of the pfSense firewall. So let's open a new tab here, and we'll just click on this to type in the IP address. And we'll click through this warning for the self-signed certificate. And we're going to log in. It has the default credentials, it says over here, admin and pfSense. So let's type in admin and pfsense, and we'll log in here. All right, now that we're logged in, let's change that password. So there's a handy little link here to the user manager. We'll just click that. It says to change the password to this value, so let's put this in here twice. We'll just click the little text button to put it in, and we'll click save to make sure that that's set. All right, now that it's set, let's log out and log back in like it's supposed to do in step number 3 here. So let's type in the new password here just to make sure that it's been reset correctly. All right, and so now we're logged back in. So the password was successfully changed. Let's go back to the scoreboard here, and we see that we've scored 5 points. So that task achieved us 5 points out of the 97. So now the other thing we're going to do real quick here is at the end, oh, not that one, this one, managing the virtual machine resources. So we're going to select the Hyper-V manager, and we'll log into this machine. We got to hit Control-Alt-Delete to log in. Once the password text box comes up, then we can put in the password. And log in. So this is a relatively simple change, and so it shouldn't take very long. So once this is up and running, we have the Windows Analyst sandbox. And if we look at the instructions, it says to assign 2 gigabytes of additional RAM. So let's just open up the settings here, click on hardware, and set it to 6144 like it says to do, and we will apply that. Close everything down here, and let's switch back to the WinAdmin machine, and these points should get scored here in just a moment. And here we have it. So we have 11 more points. So that counted for 6 of the points. So let's draw the curtain back a little bit and see what's going on behind the scenes. So this definitely would not be accessible to students in the environment, either in the assessment or the lab. This is the VirtuPort backend. Let's log in here. So this is where all the information is configured for the scoring, including all of the tasks that have to get done, but also how we connect out to our Nimbus cloud server. So that's what's configured here. So the scoring happens all in the environment automatically, and periodically, about once a minute by default, it sends all of this information to our cloud server, our Nimbus, which is our server that kind of collects all of the scoring data. And that's the machine that stores it for future reference and also can generate the reports and all that kind of stuff. So that's configured right here. If we look at the rubric, we can see the various domains or categories. And so the way we map everything to KSAs is that we have the KSAs configured as categories inside the lab. So each one of these items here is going to be a specific KSA, so you can see they're all numbered. And the tasks that we're going to look at next, they're all mapped to a specific category here, which of course corresponds to a KSA. So if we look at that, we can see that. So each one of these is a scoreable item, so each one of these rows. And what we see here is what KSA it refers to. We also see how it's going to be scoring it, whether it be some kind of file monitoring or a generic plugin. So the file monitoring, just so you know, is it's monitoring files. It can monitor for creation, modification, or deletion of files. And it can also check for specific contents of those files. So a file must contain a certain string, or it has to contain a regular expression, or the file might have to exactly equal some kind of hash value, so the exact string contents. We're just going to pull open here this generic plugin. So we see the actual rule. You can have multiple rules here if you want, so that you can have multiple ways of accomplishing a goal. But in this case, we have the machine that it's running on, so DC1, so that would be the domain controller. It's looking for the output of this plugin called GPO. So it's going to be checking group policy. And so this group policy plugin is what does the actual scoring, all the hard work of the scoring, and it's going to output the word score if it's correct. So we're not going to get into the detail of what those look like. Some of those are custom compiled executables. Some of them are scripts, and they can be lots of different things. But they check specifically for the change in state that we're looking for, and output an easily checked value at the end to see if the student has achieved the goal. If we look at the student data tab here, we see all of the data that's been collected in this environment. So it collects all the commands that are run. It collects certain files that it's monitoring, and of course it has the output from the generic plugins. If we filter this down to just see the command and response, we see the actual commands that were run and with the associated results from that command. So we can not only check the command that was run by the student, but we can also look for the results of that command to make sure that things are working the way we want them to be working in order to achieve the scoring. Like I said here, we're looking potentially for the hash of the file, or we can look for something in the contents. And here's the plugin results as well. So this one in particular is looking for the pfSense password, and it's looking for the contents here. Now, if we look at the Evaluate tab, here we see all of the individual scoreable tasks with the description here. So, for example, we have remove user from local admin group. If we scroll down, we'll see some of the ones that we did. Here we go, change the default password on the router. So we can see that this is measured by the generic plugin that we talked about already. This one was scored, that's why it's got the green check mark. And we see that's mapped to this specific KSA, knowledge of cybersecurity and privacy principles. Now, you may have noticed that we got 5 points for doing this. That's because there are multiple KSAs that this will map to, and so that's how we achieve that. So if we scroll down, we'll see multiple instances. Like, for example, here we have increased RAM on the VM. We have that twice, mapping to 2 different KSAs. So this one here, knowledge of measures or indicators of system performance and availability, or knowledge of system administration concepts. So it maps to both of those, so it appears twice. So here we have the student data. So this is important because this is how it can correlate things back to a particular user. And that way it can generate the personalized results for the training recommendations. In the reports tab here, we can see the scores for each KSA. So this is a summary for each KSA. So for example, here, the knowledge of system administration concepts. So far, we've done 1 out of the 9 tasks in that particular KSA. So out of 9 tasks that map to this KSA, we've done 1 of them, so we've gotten 1 out of the 9 points. Now, the last thing I want to show here is the dynamic environment. I'm not going to enable this because we're going to be looking at the data from this lab instance in the portal in a moment, and so I don't want to interfere with that process. But I just wanted to indicate to you that we do support the generation of dynamic environments, which can do things like randomize IP addresses and subnets, and so that way the labs are not, or the labs and assessments are not all the same across all instances. So that way 2 students sitting next to each other wouldn't have the exact same environment and therefore the exact same answers. So the next thing I want to show is the portal. So the portal is where the information gets sent to, like I mentioned with the Nimbus server. So the portal is how most training managers would interact with this data. So it's your interface to all the labs that happen and some summary information, and this is also the system that's going to generate all the reports and everything. So I already have the lab instance pulled up. So the one we were just in, this is the data from that particular lab. And so we can see that it has all the command line information. So all the commands run on the different systems. We have all the file monitoring, generic plugins. That's right, I have to refresh this data to get the latest. So we can see all the file monitoring information. We can see the generic plugins, and so on. We can also see the individual tasks and whether or not they've been completed. So this is the same information we saw in the lab itself. So this is important because whereas the lab itself, when the lab is shut down, it goes away. this data here is permanent, and so you can refer to it later. So one of the things this is nice for is that if there's some kind of a dispute later, and the student says that they achieved some task, some goal, and the score doesn't reflect that, you can actually see everything that they've done in the environment, and see if they actually did accomplish it. Maybe there's some other way of accomplishing something that wasn't anticipated or something like that. So, like I said before, this is updated in real time. So let me just demonstrate that quickly. So I'm going to switch back to the lab here. Let me pull up a command prompt here. Let me just run a command, ipconfig/all. And let's also run a dir. So first, let me just demonstrate that this shows up in the scoring data here. So let's look at the command response data. We can see here the ipconfig/all and the dir command. So now let's switch over back to the portal and we'll see that information there. So let's refresh this information. And it takes a minute, so it might not be there just yet. So you can see that it's not here yet. Let's just wait a moment and we'll try to refresh this again. And here we have the dir command. We can see it's just sorted a little bit differently. ipconfig, there it is. So we can see the results of the ipconfig command. So all the data is getting updated here real time, and it's all here for future reference. So the next thing I want to point out, or the next thing we want to look at, is the report. So let's look at the report here. So this is an example of what would be sent to a student or training manager. So we can see here the student information. We can also see the particular assessment information we're looking at. So again, we're looking at field technologist, and the sub-assessment we're looking at is the network support specialist. And we see that there was a 94, but you can see all the different attempts that the student made on these assessments. So if we look back at the beginning, we can see that first this student took technical support specialist, got a 48. They took it again, same day, got a 73. Then also the same day, they took the network support specialist and got a 59. Then, as you can see, it goes from April 17th, it goes to August 14th. So after a period of 4 months, presumably with training in the middle, they took this assessment again. So the technical support specialist got a 73, and then the network support specialist then got a 94. So this report shows you the scores that the student gets through time, and so you can see the trends and information that way. Now, if we scroll down here, we see the personalized learning plan. So each category here is organized in order of most important to least important, so it's prioritized for you. So the sections listed first are the ones that the student should take first, and within those sections, the labs are listed in order as well. So the most important ones to take first show up first. There's also an indication of whether or not the student has already taken the training. So that way you can see at a glance how much of the training plan is complete and how much is left to be done. Now these names could also be links into the lab environment themselves, so you can actually launch the labs from this report and use this as the training platform, personalized training platform. If we go over to the second tab, assessments, this is an interesting view in that it shows us the graph of scores over time. And not only for each individual assessment. So for example, we have the network support specialist. Remember, they started with a 59 and ended with a 94 between April and August. And if the student took more of the assessment, you would see those as well. You can see a graph of the progress. It also breaks it down by KSA. So you can look at the individual KSAs that were assessed in that particular assessment and see how the scores improved for that particular KSA. So here, for example, we have operating common network tools went from 80 to 100. Executing OS command line went from 20 to around 80. So you can see how well the student improved on each particular KSA. The last thing we'll show here is this work role view. So this shows the cumulative results for the particular work role. So the field technologist work role has the two sub-assessments, network support specialist and technical support specialist. So this view combines the two. So you see the different scores. So 73 for tech support, 94 for network support, for an average score of 83. Not only do you get to see this view, but you also have it broken down by competencies. So each work role has a set of defined competencies associated with it. And this view shows the scores for each one of those competencies. So that kind of really draws out right away which areas the student really needs to work on in terms of competencies. So operating systems, information technology, performance assessment, and so on. Now the last thing I want to cover here is an example lab, just to get a look at what a lab would look like, not just an assessment. Since we're not going to really do anything in the lab, I just want to show you the instructions. Let me just open this up a little bit. So the lab, as I mentioned before, is going to be just one about scanning with Nmap. It's a relatively basic lab, but the idea is that we really get into why things work the way they do. That's kind of one of our pedagogical goals, is understanding the why behind the what and the how. So just to show some of the instructions here, so we start with the ping scan, which is really basic scan to see if machines are up and available. You could just cover it by saying you run it with nmap-sp and it'll do the ping scan. But what we do is open up Wireshark first, and so that way every time we do a scan, not only do we see the actual results, but we look at what the traffic looks like. So for example, here we're doing a ping scan on a local network, and we notice that since it's a local network, it's doing ARP scan instead of ICMP or anything else. Now when we do a more distant network, we see that by default, with a limited privilege user, it does a TCP scan, but if you're root, then it does the actual ICMP scan. So for each of the combinations of ways of doing things, and not only just how we're running it, but what we're testing against, it shows how what actually happens behind the scenes changes. When we talk about basic port scans, not only do we do a scan and show the results here, but we also see what goes on behind the scenes. So here we're looking at the actual TCP three-way handshake for open ports and for closed ports, so you can kind of see what the difference is in terms of the different results that you get back. And again, we look at the difference between limited user account and also the privileged user account. So we see the different way that scans perform, even though we're running the same command, just with different privileges. And then we have the students go through an experiment with some of the more exotic types of scans, and they get to see in Wireshark what different flags are set, what the different operating systems respond with. Here we show a UDP scan, and again, it shows how it goes into a little more detail. So really the only way to know if a UDP port is open is if you can actually interact with it, because it might be open and just not responding to you. So here we see that it actually sends an SNMP request, and it gets some results back, so that way it knows for sure that SNMP is open. When we talk about the timing options, we go in and look at how the different timing options interact, or change rather, the actual timing. And so you can see in Wireshark the timing between the different packets. We can see that actually 15 seconds elapses between each scan. And that's the amount of time that happens with a -T1 scan. When we talk about OS and protocol fingerprinting, it's the same kind of thing. So again, we run the scan, and then we look at the traffic and understand why it's returning the results that it is. How is it getting the information that it's getting? So it's actually getting the banner from the FTP server, or in the case of a web server, it actually gets the banner and then returns the server header. In the case of OS fingerprinting, it's similar, but you get to see some of the probes that happen behind the scenes, how the operating system is responding, and so therefore why the tool returns the values that it does. Next, we move on to script scanning. So not only do we show where the scripts are, we look at just the basic operation of a script. We look at the results, and then again, we look at how it gets those results. So we're noticing in Wireshark that it's actually retrieving certain values, and based on those results, it knows what the answers are in terms of the version that's running. And when we compare that with the actual script itself, you can see that it's going to get in this case, an image, compute the MD5 hash of it, and use that hash to actually look up the value of the PHP version. And it's really important to get this level of detail because you really understand why the script is doing what it's doing and why the tool is doing what it's doing. And so that way you can use it optimally when you're actually using it in the real world. We look at some additional options. Here we're setting the source port. So we notice first that when you do a scan, it has a random source port. And then when you set the source port with the -G option, you see that the source port is actually set to 53 in this case. Next, we look at an IP version 6 scan. So it's just a little bit different in how you set the address value. And then the last thing that we do is look at the output options. We see how the different output options can be formatted differently. We have the regular results, we have the greppable version, and then the XML version, and so on. So that's just kind of a brief look at one of our labs and kind of the level of rigor that we attempt to put into all of our labs. And hopefully that shows you some of the pedagogical philosophy that we approach our labs with. So to recap, in order to train the next generation of cybersecurity professionals, we need to focus on developing the skills needed for the particular job roles that we have. We all have tight budgets and need to get the most cost-effective training, getting the best return on our investment. We propose that to do this, we need to make use of a cycle of assessment, personalized training, and reassessment so that the skills that are lacking are the ones that are taught. We have assessments for 8 job roles currently, with more on the way in the upcoming years, and over 400 hands-on labs that can provide the individualized training to bridge the knowledge gaps in our workforce. We also have the data collection and analytics to give highly detailed technical information about the students' performance in the labs and assessments in order to deepen our understanding of the educational process. Our contact information is listed here if you have any further questions about our process. Thank you very much for your time.